All right, let's look at a position time graph where the slope is changing. So we have a curved line, meaning the slope is changing all along this. The slope of this line is changing all along the motion. So we have an object moving some distance along this number line, the y-axis, over some amount of time, the x-axis. And we can find on this curve the instantaneous velocity. So the instantaneous velocity is the distance divided by the time at any instant or given point along this curved line. And it is the slope of the tangent to the line of the tangent. All right. So on this moving object at time equals 0, so at 0 seconds, the slope of our line is about that, or the slope of our tangent. Before we even get the slope, we can see that this is a positive slope, which means that the velocity is positive, it's in the positive direction. And the steeper the slope, the higher the number is going to be, so the faster the velocity is going to be. So we can see as we go along this motion in time that the slope of the tangent gets less and less steep until it gets to the top here where it's actually 0. So for an instant, this object, whatever it is, stops wherever the tangent line is 0. And then after 3 seconds, from 3 seconds to about 9 seconds or so, the slope of the tangent, so the velocity, is negative, meaning we're moving in the negative direction. And then as it gets closer to 9, it goes back down to 0. So the slope of the tangent around 7 seconds is negative. So we'll just draw that. So those are the instantaneous velocities at 0 seconds, at around 3 seconds, and at around 7 seconds. Now you can also find the average velocity on a graph like this too. So the average velocity, and that's going to be the slope between 2 points. So the slope So you'd talk about the average velocity between, let's say, between 1 second and between 1 second and between 8 seconds. So the average velocity would be the slope of the line between these 2 points. The slope of this line. So to calculate the slope, it's the change in y over the change in x. So we have maybe 1, 1, and 8, -4. So we have -4 minus 1 over 8 minus 1 gives us -5 over 7. And we put that into our calculator and we get a -0.714. So we get a small negative slope for this average velocity. So this is the average velocity would be in meters per second. All right, so from a slope or a graph like this, you can get instantaneous velocity and average velocity by doing this. The line's tangent to the curve and then the slope of the line between 2 points.